Picture this. It is Monday morning, 9:01 a.m., and your CTO asks your shiny new HR assistant, built on retrieval augmented generation, one simple question. Who can join Project X right now that is not tangled in Bob's audit mess? The agent thinks, spins, and confidently returns three names. There is just one problem. All three people were moved off Bob's team in the last hour, and your system has no idea. In other words, your real-time AI is already out of date before the coffee finishes brewing. Here is the uncomfortable truth. Most RAG systems today are built on vector databases that treat your company like a static PDF manual. They are fine for evergreen questions like, what are good science gifts for a 10-year-old? But the moment your world starts to move in real time, those embeddings turn into a ticking time bomb. In this video, we are going to dismantle that bomb and show you the Graph RAG architecture that can actually keep up. Let us start with why your current setup is doomed on dynamic data. In a typical vector RAG pipeline, you dump documents into a vector store, embed everything once, and let semantic search find similar chunks. That works when nothing important changes for weeks. But ask yourself, how often do promotions, team reshuffles, and project assignments change in your org? Daily, maybe hourly. That gap between reality and embeddings is where bad decisions are born. Take a simple fact like Alice reports to Bob. In a vector database, that sentence becomes a dense point in a high-dimensional fog. You embed another fact. Bob manages the platform team, and a third platform team is under audit. Once they are all vectors, the explicit links vanish. You no longer have a chain, Alice to Bob to platform to under audit. You have three isolated vibes that the model has to guess its way through. Now imagine asking, who reports to someone whose team is under audit? With vectors, the language model has to mentally rebuild a graph that no longer exists. Systems try to fake multi-hop reasoning by over-retrieving more and more chunks and hoping the model stitches them together. That means bigger prompts, more irrelevant text, higher latency, and rapidly falling accuracy after 2 or 3 hops. And here is the part nobody tells you. Every extra hop compounds noise until your so-called assistant is just an expensive autocomplete. Time makes this even worse. A standard vector store has no real notion of when a fact was true. The embedding for Alice reports to Bob looks identical whether it was accurate last year or 5 minutes ago. You can slap timestamps into metadata, but the similarity search itself is blind to temporal validity. So when reality shifts, you are stuck re-embedding huge document sets just to stay roughly correct, burning GPU hours and spiking latency every time HR pushes an update. Graph RAG flips this entire mental model. Instead of flattening everything into vectors, it keeps nodes like people, teams, projects, and rules, and edges like reports to works on, and under audit as first-class citizens. Alice reports to Bob, and Bob's team is under audit stay as explicit facts you can traverse. When Alice gets promoted, moves under the CTO, and jumps from Project X to AI strategy, you just update a handful of edges in milliseconds. No N-sized re-embedding, no overnight batch jobs, no cache invalidation nightmares. Here is where it gets powerful for reasoning. Need a front-end expert who is not on Bob's team, whose team is under audit, and who has never worked on AI projects. A graph engine literally walks the path, candidate to skills to team to projects to compliance rules, enforcing each constraint hop by hop. Accuracy does not crater after 2 or 3 hops because you are not guessing structure from text, you are traversing it. And in a minute, we will plug this into a real tech stack you can run yourself. The numbers back this up. In Falkor D B's own benchmarks on complex, multi-hop enterprise queries, traditional vector RAG hits about 57.5% accuracy. Swap and graph RAG powered by a temporal graph, and you jump to over 81%. Same language model, same questions, just replacing fuzzy vector hops with deterministic graph traversal. That is a 24-point gain without touching the model weights. This is not a tiny optimization, it is an architectural shift. So what does this look like in practice? In the Yeyu Labs demo, Graph RAG is not just an idea, it is a working stack. Falkor D B, Graphiti, and Google Gemini wired together through an agent development kit. Falkor D B sits at the bottom as the high-performance graph store, compiling your graph into sparse matrices and running traversals as linear algebra. Graphiti layers on top, turning that into a temporal knowledge graph that remembers how your org changes over time. And Gemini handles the natural language, tools, and even voice, turning human questions into precise graph queries. Falkor D B is not just a prettier graph database. Under the hood, every relationship becomes part of a giant sparse adjacency matrix. Queries like who reports to Alice's manager's manager turn into a few matrix multiplications instead of millions of pointer hops. That means multi-hop queries and neighborhood expansions stay fast even as your org chart grows to millions of edges. And operationally, it is simple. You spin up the same stack from the demo with a single Docker run command and get a live UI plus a Redis-compatible API. On top of that, Graphiti turns your graph into a time machine. Instead of overriding Alice used to report to Bob and now reports to Sarah, it stores every change as an episode, a time-stamped bundle of facts. Each edge carries a start time, an optional end time, and a validity flag. When Gemini asks, who is Alice's manager, Graphiti injects the time dimension as of now, as of last quarter, or right before the audit started. Suddenly, questions like who managed Project X right before the audit become first-class queries, not impossible archaeology. This temporal model is where vector databases simply cannot compete. Re-embedding the HR corpus after every promotion only gives you the latest snapshot, not the sequence of states you need for compliance and forensics. You cannot easily ask which engineers ever worked under Bob while his team was under audit using pure vectors. Graphiti bakes the event store into the graph itself, so temporal edges sit right alongside skills, teams, and projects. Multi-hop queries with time filters run as a single traversal instead of a brittle mashup of logs and embeddings. Now, how do you actually build this? In the demo, graph construction starts in a single Python file called setupgraph.py. Instead of handwriting complex cipher or schema files, you stream natural language descriptions into Graphiti, which then talks to Falkor D B. You point Graphiti at the running database, pass in your Gemini API key, and define a few high-level episodes that describe your company. Short paragraphs like in March 2025, Alice Johnson is a senior front-end engineer on Project X reporting to Bob Thompson. From there, Gemini helps turn those natural language episodes into structured nodes and edges. People, teams, projects, and relationships are inferred and inserted into Falkor D B with temporal metadata attached. You are effectively letting the language model help you build the knowledge graph, but storing the result in a deterministic, queryable structure. In other words, you get the creativity of LLMIS during ingestion and the reliability of graphs during retrieval. This changes who gets hired next to build your agents, because graph thinking becomes a core skill. Let us zoom back out to the real stakes for you. If your assistant is helping staff sensitive projects, answer compliance questions, or reason over live supply chains, stale data is not just inconvenient, it is dangerous. A vector-only RAG that lags reality by hours can put the wrong engineer on a restricted AI project or miss that a team is under audit. A graph-native temporal RAG can answer who can join Project X right now with millisecond fresh context. The difference shows up in hiring decisions, risk exposure, and ultimately trust in your AI. So here is the big takeaway. Vector search is not dead, but it is no longer enough on its own. Use vectors to understand language and find relevant concepts, but let graphs handle structure, relationships, and time. That is what Graph RAG really means, retrieval that thinks in connections instead of static chunks. If you are building real-time agents for HR, compliance, logistics, or any domain where the world changes under your feet, this is the architecture you cannot ignore. If you want to go deeper, explore Falkor D B's sparse matrix engine, read the Vector RAG versus Graph RAG technical breakdown, and study Graphiti's temporal episode model on GitHub. Then try wiring up your own small talent graph with a handful of employees, teams, and projects, and watch how easy it becomes to answer questions that used to be impossible. And if you want to follow up where we walk through the actual code and a live demo end-to-end, tell me in the comments. Make sure you subscribe so you do not miss the next part of this series, because real-time RAG is where the future of enterprise AI is actually being decided.